Hello, hello, Shagat the Known here. Welcome to what is my first coding stream. I don't know how this is going to go. Maybe no one shows up, but I am recording this for YouTube, so I'm going to kind of narrate it and do things just like I would do for a YouTube video. And yeah, I've been talking about wanting to do something like this for as long as I've had this channel. So yeah, here I am finally. I've finally got around to doing something. Today, I had an idea of something I wanted to do. Really, I have an idea of like maybe a larger project of something I want to do, but I haven't done a coding stream or anything, so I wanted to, kind of test the waters and just, maybe get a setup going here to work with. And so what I thought today is I would do a quick demo of something that can kind of lead into this larger project that I kind of want to do. And then maybe I'll do that entire project on coding streams or something. I'm not sure yet. So what am I going to do today? Basically, we're going to kind of pretend that I'm making like I don't know, like a little dummy app. Like we're not really going to make a web crawler, but I'm going to go over like the Serde crate in Rust and kind of talk about how you might use that to like do a config or something to read in configs that might help control your app. So it allows you to separate your main code that you're writing, separate those config parameters and such, so they're not having to be hard coded. Serde I've found is a great way to do that. There are other ways to do that, as is always the case in programming. When you write code, there's 80 different ways to do it. Your way is not the only way. There may be some better ways that you're not aware of, or you may have picked a pretty good method to do something. So in cases where I know of other ways that we could do it, I'll try to point that out. Like, alternatively, there's this or that. I'll try to point that out, and I'll try to basically explain everything that I'm doing as I'm doing it. But this is not necessarily like a video dedicated to teaching Rust. Now, again, I'll describe things as I'm doing them, but I'm not here to like teach Rust. So the first thing, we'll just comment, again, I'm going to try to go into detail where I can. So I've just made a new cargo project called Serde demo. So it'd be like cargo new Serde demo. You run that, you get a new cargo project. I ran it in the D repositories folder. So now we have this Serde demo folder. Open that up here in VS Code, which is my editor of choice, my IDE, if you will. And the main things I'm going to care about are the main.rs over here and the cargo.toml. So, of course, in Rust, your cargo.toml is where you bring in your dependencies. And there is a syntax here that I'm not sure if I'm going to remember, so I'll probably just look it up and confirm and copy paste this one in here. But we got to add our dependencies, and you could do this by going to crates.io and actually finding the dependency there. It'll also let you get the dependency from docs.rs. There are a handful of places you can get this. I'm lazy, so what I can actually do is this, and is it not Serde? Or it is, I think. No. Okay, so this is the part to say where it's not like scripted or anything. Why is that one? We'll just copy this from something else. I knew I was going to need to, yeah, now it's happy. That's fine. I knew I was going to have to copy this one probably because I never remember the syntax to do the features. And what I really want here is the derived features. But I'll show the other thing I wanted to do in a moment. But first, let's actually hop over to the browser and talk about Serde for a moment. So let's see if this button works now. It worked before stream. Perfect. Beautiful. So Serde is a framework for serializing, that's the SER, and deserializing, that's the DE in Serde. So you serialize and deserialize Rust data structures efficiently and generically. Serde ecosystem consists of data structures that know how to serialize and deserialize themselves, along with data formats that know how to serialize and deserialize other things. Serde provides the layer by which these two groups interact with each other, allowing any supported data structure to be serialized and deserialized using any supported data format. And we can go to serde.rs for additional info, and I think that's what I have open here. Ah, that's blinding though. We need a dark theme on this. There might be a place to turn that on, but regardless, it doesn't matter at the moment. So we can get some more information here, and all these data formats are kind of what I care about. So they're also listed here. So this is a partial list of data formats that have been implemented. We're going to look at a subset of these. So JSON is pretty standard, and JSON 5, it's a superset of JSON. It's very, very similar to JSON, and in most cases, it's going to be pretty much identical, but it allows for some nice things like hex numbers. It allows for trailing commas. If you write a lot of Rust, you probably do a lot of trailing commas. So that's cool. YAML, super easy. We'll do that. We'll do TOML. We'll do Ron. I haven't actually used Ron in a long time. I kind of forgot about it, but Ron should be cool. And we'll do, I think I had one more in mind. YAML, TOML, JSON. Yeah, that's probably good enough. I mean, we have a handful that we can try here. So this is what we're going to be doing. We're going to be pulling in a bunch of these, and we're going to just kind of demo how this works. Should be pretty straightforward. Shouldn't actually take that long. This may be over in 20 minutes. This may be an hour. Who knows what's going to happen. So we're going to add some extra dependencies here. And now what we could do is I could go click on any of those in the browser to actually we'll go back and we'll look at one real quick. So let's say JSON. I think I've already got it open, but it brings us to GitHub here, and it tells us the dependency is Serde JSON. So we would add Serde JSON, and it says 1.0, but it looks like 1.0.83 is actually the newest release. So let's actually check out what the thing here says. So let's say we want to add Serde JSON. We'll do that. And now this is where I said I like to be lazy. So we actually have a check here. And this comes from the crates.io extension in VS Code. And it's complaining because it's like, yo, we need a version, right? But by putting these empty quotes here, that's enough to get this thing to pop up when I mouse over it. And I can just click on 1.0.83. Boom, it's in there. That allows me to do this. If I know the name of the dependency, I don't have to go to the browser. It'll just give me the newest version here. Now, there are other ways to do it. Is it JSON-5? Let's see, underscore JSON 5. There it is. It's just JSON 5. So we do the same thing here, and we see the version is 0.4.1. We can put a star, and I believe that wildcard just tells it, hey, we're gonna pick up anything we can. So whatever the newest version is, go for it. Now that's fine, but you might have a problem where it introduces breaking change. So you know you're running your code a month later, some change happened. It might actually break your code if you're not careful. And I think there's a similar thing here too, where you could put a caret. No, that's not it. I don't remember the syntax for that. Is it a caret before? Yeah, so you can put a caret before, and I think that says minimum version of 0.4.1, and then it'll allow anything beyond that. But don't really like doing something like that because of the aforementioned issue. I like explicitly defining what my versions are going to be. So we'll just do a couple more here. Let's see, 0.5.9 on TOML. So we have JSON. I think Serde YAML is the name. Yep. And it should be good enough. We'll do Ron. Is it just, it is Ron. Cool. And now the other cool thing is I could click on this docs link here and it'll actually take me to the docs page for it. So nice little integration here. It's just one of the extensions you can pull in. Not better TOML. Cargo? No, not crates. It's just the crates one here. I got a lot of stuff going on in here. We're not going to go over that right now, but you know, maybe I will if anyone's curious about it or something. So here we have some dependencies, and well, we want to use them, right? So the first most important thing is, in order to do what we're going to talk about today, we're going to need Serde, and we're going to need the derive feature, because we're going to use it to derive implementations for serialize and deserialize on structs that we build. And that's going to really be the crux of it. Now, there's other things you can do with Serde. That's not really, I'm not trying to do an entire overview of Serde. I'm not really going to go do a custom implementation. I might end up needing to do that in a larger project, depending on how this goes. But right now, we don't really need to do that. So this is another one I need to confirm the syntax on. And I've got another program I just wrote the other day. I always forget how to do, is it just use Serde? Yeah, it is. Okay, it's just use Serde. Okay, it's not as weird as I thought. I think in the past there were some oddities with it. So use Serde, and then you see it actually, it's kind of pulling both of these in already. There's some like AI completion stuff going on here. It can be a little annoying. Sometimes I want to turn it off. Now I'm bothered because I put them in the wrong order. That order just bothers me. Just ignore me. Okay, so we're going to be using both of those. I know it's complaining right now because I'm not using them, but that's the biggest thing we need at the moment. So what we could do is we can do a cargo run. We could do cargo build as well. Not cargo run. And it's going to go ahead and pull down all the dependencies that are needed for each of those crates that I just input, as well as pull in and build those crates as necessary. And it's going to go ahead and run our code and we get our hello world. Simple. So everything seems to be fine for the moment. So what are we going to do? And what's this little like sample dummy program that I'm talking about? Let's imagine that we're building a web scraper. And we don't want to like define things like what websites we're going to scrape and such in our code. We don't want to like build a vector here, you know, and define like some website, right? We don't want to do that here. So we want to be able to pull that in dynamically from a config file, so we're not having to recompile every time we change something like that. I think it's pretty basic stuff, right? You've done any decent amount of coding, that should make sense. I don't really need to beat that dead horse anymore. So the idea is we want to be able to take in certain things from a config file. So naming doesn't matter. You can call it whatever you want. But we're going to make a new struct. I'm going to call it config. I'm going to call it scraper config because the naming really doesn't matter. You know, there's nothing special about whatever we name it. It's just a struct. So with this struct, we need to think about what kind of things we want to put in our config that we might have a web scraper read in. So the first thing, and I think the easiest thing, is we want to be able to define a list of URLs to scrape. So that seems easy enough. URLs, and we're just going to say, it's even already recommending exactly what I wanted to do. So we're going to say URLs is a vector of strings. Pretty straightforward, easy. I also want to imagine that we have this concept of a maximum depth. So what do I mean by depth in this case? If you're a web scraper, you load up a web page and you go through and you crawl some data, you know, you grab a bunch of data from it, but you also get every link from that page. So the initial page you start on, that's a depth of 0. But then every link on that page, if you were to go down and scrape those links, that would be a depth of 1. And then if you were to get all the links from those and go down again, that would be a depth of 2. And you may be seeing that this would expand very quickly. It would pretty much be unmanageable if you go too many layers deep. So maybe you want to allow it to go a couple layers deep, but you don't want it to go overboard. So you want to be able to set a max depth. So we're going to say, we could do like usize or something, but I'm going to say U8 because I'm imagining with like 255, we have plenty, like we don't need that much. So, you know, we could go with that. And that should imply we get a little bit of error checking as well when we're deserializing to make sure that we're not reading in a value that's larger than 255. So there's that. And then I'm going to go ahead and imagine that maybe we crawl all these websites, we do our web scraping, and then we want to save some information from like whatever it is we found, right? So, you know, this is just going to be something like output file, and it's just going to be a string. Now, the whole point of this is, again, not that I'm actually building a scraper right now. This is just to throw something together to be able to kind of demo something I like doing here. And then again, I have an idea of something I want to do in a future program that I think could be pretty interesting, but this is just kind of the initial, like, here's a way you can use Serde, and there's other ways to do this as well. So what we want to be able to do is read in a config and from some file, and we're going to have this struct here with all that information from our config. So there are a handful of ways to do this, and I mentioned earlier what I don't want to do is I don't want to just say, oh, this is the only way to ever do something, right? We have to realize that there's always like 80 different ways to do something, and there's actually a config crate that does a pretty good job at a lot of this stuff as well. And I think it's probably using Serde under the hood. Don't quote me on that, but it would make sense if it was probably using Serde under the hood. So there's other ways to do this, but this is just something I found myself doing more lately, is just using Serde itself. So in order to actually use Serde for what we're talking about here, we need to go ahead and make this struct serializable and deserializable. So, well, really you only need to be able to deserialize it, but I'm going to do both for a reason, because I'm lazy. So we're going to do derive, and we're going to say debug, and we're going to say serialize, deserialize, and let that auto-complete it, and boom. So we got debug, we can print it out now, that's cool. And we can serialize and deserialize it. So what I meant by I'm lazy is I don't want to actually build out a config file. And in this case, it'd be pretty easy to build out like a JSON file or something. This is a pretty straightforward data structure here. But I've dealt with some much more complex data structures with a lot of enums, even some like nested enums, or like self-referential enums, and some weird stuff. I've dealt with some stuff that was a lot harder for me to just look at and say, oh, I can easily make a JSON file for this. And now let it happen programmatically. I'm going to make Rust do it for me, because I'd rather write Rust than JSON, at least to get the initial like structure, if you will, of the JSON, of the config file itself. So that's what I'm going to do here. I'm going to demonstrate how we can go ahead and just build out like a dummy config file, and then you can modify that more as you go on. So what we want to do is we want to go ahead and make one of these configs in our main here, and then we're going to use Serde serialize to turn it into like a JSON string, and we're going to save that to a file. So in order to do that, well, let's just say let, it's already recommending exactly what I want to do. We're going to say let config equal, and scraper config, and then again, I like to be lazy, so we'll just have this fill the struct fields for us, and we need some URLs, so we're going to scrape Google, because that's the best thing you would ever scrape in a web scraper. That's not how you make a web scraper, by the way. CNN, is it just fox.com? Whatever. That's good enough. We got 3 of them there. And actually we need to make those regular strings though. Can I do an into on that? I always forget. Yeah, we'll do an into on that. From the deserializing side, it's not going to be a big deal. But here we're just trying to get something saved into the file. Max depth, we're going to say 2. So from every link we find in a page, we're just going to go 2 layers deep. And so starting from like CNN.com, we're going to grab every single link. And then from every single link there, we're going to go down 1 more. So that's again how the max depth would work. Again, this is not a real web scraper, so don't expect it to actually be implemented. This is a sample, and I'm going to explain what I'm interested in trying once I get done with this. So output file is going to be scraped info dot what format do we want it to be in? I mean, it doesn't matter. We'll just say .txt. Actually, no, we'll say JSON 5. Okay, and there we go. So that is our config struct that we've kind of defined up here. And now how do we go about getting that to actually show up in like in a file somewhere? We need to serialize that. Click on something over here. We need to serialize that, And the way we want to do that is, let's say the first thing I want to do just as a sample is JSON5 config equal, and it's going to be JSON5 dot right here to string, and then we feed in a reference to our config. And I'm going to do the good old unwrap. So what this is going to do is it's going to go in, it's going to attempt to make a JSON5, or not just a string. It's just a string. That's all it is. I mean, we could see here the inferred type is just string. And I can actually explicitly type it out here. So it's nothing special. It's not some special like JSON5 data structure or anything like that. It's literally just a string. But that's all JSON is. That's all really anything is. I mean, this file here is just a long string. So that's fine. And then we want to be able to save that to a config file somewhere. And forgive me on this, I'm slipping. There is a simple way to do this that I am slipping on right now. So I'm going to double check because I think I have it. I think I have it still in one of my other. I don't have it there anymore. Damn. Okay, let me double check one more spot. This was, as I think I mentioned, this was all. There's no like script or anything, so that's that's fine. Things happen. Okay, I gotta look up the right real quick. So let me switch over to the browser, and you can see what I'm doing. Okay. So we're just going to say write string to file. I did this the other day, but I forgot. There's like a really simple like one-liner basically that we can do here. That'll probably do the trick. I think there's an easier way with the write macro though. So let me take a look at the write macro. Write in std. Let's take a look at it. Where are we at? It's not really showing an example with a file, but that's what this is here. This is like our file buffer. I mean, in this case, they're writing to a string, they're writing to a vector, but we can use a file buffer. Alternatively, we can probably just go and grab this here, and this will work just as well. So let's do that. And to do that, we need file and prelude, or we need, yeah, so let me copy all this. It's gonna paste in as garbage, but I don't feel like going back and forth. So let's just slap this right here. Let's grab those. Let's get rid of this extra main. And we should be good at formatting wise, but I'm going to do, there we go, it's even better. And yeah, we can't do those. Again, unwrap is fine sometimes. This is a prototyping, this is a demo. It's perfectly fine to do an unwrap. So here we're going to say JSON, we're going to say config.json5. I don't know that the format, that the dot really matters too much, but that's how I want to do it. So we're going to make that file, and hopefully it works. And then here we're going to bring in the string. Okay, so it wants as bytes. Yeah, that works. Cool. So there we go. So write all. If we look here, it wants a U8 buffer, essentially. So if we look at as bytes, that gives us that exact array that we were looking for, the slice. So there we go. And then we're going to print hello world because why not? We'll do cargo build. Everything seems happy. Do cargo run. And boom. Now over here we have config.json5. So this is what I just generated. And here it is. Now, for some reason, I think it's because JSON 5 just doesn't have as much support. I actually have a VS Code extension that does support JSON 5. It will allow me to do Alt-Shift-F to format it, but for some reason, it always comes out on a single line like that. It's not very pleasant. That's the biggest problem I have here. But what we see here is it's created this output here that is basically almost the same thing as what we defined here. In fact, if I split this, we can see the two side by side. They're very, very similar. Obviously, this has some Rust syntax and needing, like, we're defining a vector, so we're using the vec macro here. But it's almost identical. So pretty cool stuff, pretty easy. Now, imagine that we had a much more complex data structure. Imagine that we had something nested, especially. This is where it really shines. And in fact, I can maybe force it to do something like that here in a minute. But before that, I want to take a moment to just add a couple more of these in. So what we're going to do is we're going to say JSON config. As it's Serde JSON from string. And it's going to be same thing basically. Oh no, toString, excuse me. toString. Okay, let me see. Weird. Yeah, whatever. I feel like I just did that and it was mad. So all we're gonna do is copy this exact same thing and change this to JSON. And this. And now we're gonna do the same thing once again for YAML and TOML. So I'm gonna refactor that. And boom, that looks good. And then all I gotta do is change which crate we're using here. So this is just TOML, and this is Serde YAML. And also Ron, there was Ron, so let's try that as well. I have used Ron once in the past, and it's cool. I kind of forgot it existed until just now. Do we have yeah, we have toString. Perfect. We're just gonna say Ron config. I don't know what extension would be used, so we're just gonna try that. And cargo run. Now I should see a bunch of files pop up here. So we have JSON 5 already, we have JSON, we got the same single line output here. There are multiple formatters, whatever. We can see it's basically, it's the same thing as what we had a minute ago. Ron here gave us a marketplace has extensions that can help. Let's check it out. VS Code Ron, do it. Rise of Nations scripting, love it. Okay, where did Ron go? There we are. There's no formatter, but that's fine. So, you know, sometimes you'd like to see some better formatting on some of these, and, you know, you might run into a couple oddities like that. But what this does, it gives you the basic structure of how you want these things to look. TOML looks beautiful. The problem is TOML is, I believe it's Tom's obvious markup language. It's a pretty simple markup. So there may be things that TOML does not support that you would want it to, that you would ideally hope it supports. I've ran into that before with some of my more complex data structures. So that's a thing to keep in mind if you're going to use TOML. YAML, also pretty simple. It supports a little bit more complexity than TOML. So in a case where TOML doesn't work, YAML probably works. And I kind of prefer it over JSON, to be honest. But hey, JSON's pretty easy too. JSON 5 is pretty nice. It's hard to complain about that. And again, these are very simple. These are very simple data structures that I'm working with here, so it's not really anything special. So this is, again, how you would lazily create your config file. Now, we could add more here. We could say potatoes.com. We could, like, if we run it, we're going to get new config files because we're actually generating them every time. We're going to get new config files, and it's going to actually have that potatoes.com in there now. I mean, it's simple. Should be pretty self-explanatory. There we are. So what I wanted to do is think about, let's maybe make something a little more complex. And I'm going to, for a moment, just throw the notion of a web scraper out the window. And I'm going to say enum command. And because I'm lazy, I'm going to pull this from a program I wrote the other day. And just make this one nice and quick here. And then just to confirm, yeah, I just did a vector of commands. So we're going to add a vector of commands in here. I made a little bit of a macro kind of program the other day, if you want to call it that, where it can run these different commands. So let's take a look at what that might look like if we add one of these in here. So we say commands, and we say, we'll make a new vector. And then here we go. So we're going to say, okay, let's just copy all of the, we're going to do one of all of them. So let's just copy that entire block there. Trying to make this as quick and easy as possible. So we need 12. And we'll deal with that hash set in a minute. We'll say 373. Oops. What's the number? 373 times 7, 21. It's Halo reference. 20. No, that's not right. Oh, wait. Is it 343? Yeah, it's 343 and 2401. Penitent. I don't remember. 2401. I mean, why not? Put some fun stuff there. Loop. We're going to do 100. Wait. 500. And there we go. So we need a vector of commands. So this is going to be vec. And we're going to say left click, left click. We're going to put another wait in there. Just want to demo how some of this more complex stuff may function. Just to show what we can get here by using, I don't know why I keep hitting backspace instead of delete. By using Serde, we can generate these complex config files with very little effort. So we need a key combo here, which is a hash set. So I'm going to say, let's see, is there an easy way to do this? We should just be able to put these scopes around it. And let key combo equal. And we'll say new, whoops. Comparison operator, we don't care about that. And then we're going to say, we need to make that mutable. Then we're going to say key combo dot insert 12. $13 and $14. Whoops. And then we'll pass key combo out of there, and boom. There we are. It's a lot more complex now. This is our config. Nothing to do with web scraping at this point, but we're just trying to make this more complex. So let's run it. And we panicked. Now, the reason we panicked is probably because this is too complex for TOML. That's going to be my guess. Line 76. Yep. So when we tried to turn this into a TOML string, we actually failed because unsupported type. Now, unfortunately, I don't know what the unsupported type is. I don't know where it actually failed, but I think it has to do with the enums. This is actually something I ran into just a few days ago when I was building out this macro program with these weird enums and all that. So what I'm going to do just to, demonstrate this for the other config types, we're going to comment that out. We're going to run it again. We'll see. It should be able to work for, yeah, it works for everything else. So JSON got a lot more complex, but it doesn't want to format, and I don't feel like configuring it. JSON, how do I refresh this? All right, you know what? Close it. Don't save. Let's just reopen them all. JSON, JSON 5, Ron, and YAML. All right, JSON's whatever. We'll format this one. It's about the same as JSON anyway. So now we have this much more complex config file that we generated here, where we have a vector of commands, and then these commands are the enum variants that I created. So the enum variant key takes in an integer. I believe it was an i32. So we've had to actually give it an i32. Enum variant left click, middle click, right click, those don't actually take in any values. If we go back over here to where the enum is defined, left click, middle click, and right click don't actually need any values. So we see how they're actually described here with just a quote around them. And then we just put a comma, we move on to the next thing. But anything that needs a value, we kind of have to define it in this format here. Set mouse location actually takes in two values. If we look here, it takes in two i32s. So we can see that the way set mouse location works here is it's like you basically build an array. And then loop itself is a similar idea. Loop takes in an i32 and then a vector of commands. So all this complex stuff just got built out for us. And the other day when I wrote this program, I had no idea how to represent this in JSON, but I could make Serde do it for me because I'm lazy. And I like that. I find it easier to write the Rust code to do this. And then if I want to modify this file later, oh, it's easy. Oh, I need another loop. Well, let's just copy this and then modify it. And I can easily edit the JSON later. Ron, I wish this was formatting. That's the... Yeah, do we have a Ron format? We don't. That sucks. Well, that's not something I'm going to bother with right now, but it looks a lot like a mixture between Rust and the JSON. See here in loop. No, that's not fair. It's more Rust-like. It's supposed to be because it's Rusty object notation. But we see that they define the array just like the JSON. That's why I was mentioning that. So they define their arrays. Simple enough. YAML, much easier to see because it formats for us. YAML has this weird format when you're dealing with like arrays and stuff, where you have like this, I think the exclamation, the exclamation is used when you have a value in an array, which is why, well, except here for left click and left click, I don't know. YAML's weird. I mean, again, all I know is I can make Serde and Rust generate this config for me, at least my initial config, and then if I need to make another loop, if I need to do anything again, it's easy to reference what I've generated here. That's the takeaway, and that's the main thing I want to be able to demonstrate there with creating the configs. Now, there's a secondary question of how we actually use those. Actually, let me take one more look at this extensions real quick. Align text in an easy modern CSS. Why would this format Ron? I'm curious. Let's take a detour real quick. I was about to say, is it literally, there's someone named Ron in here, or Ronil. Yeah, Roni. Okay. It's hard to tell when it's all put together with no capitalization. Roni. Looks like it might be a Finnish name, just guessing. Laukarinen? Laukarinen? Maybe. Anyway, let's go back to the code here. So that was a long roundabout way of showing how we can take even very complex config file or complex data structures and turn them into config files. Now, that's a good way to get your initial config file going, but what you don't want to define this in your Rust code. This is like the prototype. You got your config built out, then you can modify it if you're lazy like me. But you don't actually want to be building this in your Rust code, because you want to be able to decouple that config from your code. That way at program startup, or maybe at some point in your program when you say, I need to read a file in and I need it in this format, you can do that. And the way we do that, what we just did was we serialized this scraper config into all the different formats here. We serialized it into JSON and JSON 5 and YAML, and tried to do TOML, but it got too complex and failed. But we did it for RON as well. So we were serializing. Deserializing it, as it turns out, is basically just as easy. And that's what's so absurd to me is, you know, coming from other languages, there are a lot of simplicities, there are a lot of nice things that you can do, but outside of something like Python, it rarely feels this easy to do something like read in a config file and have it into a data structure like this as it does here in Rust. And again, it's just the power of Serde at work here, and then these different crates. So just as a quick detour, what's actually happening with these crates like JSON 5, does it give us, so it yeah, it's a superset blah blah blah, but if we scroll through it, yeah, deserialization, it implements Serde's deserialize trait. So when we do this derive, deserialize and everything, what we're able to do is we're actually getting these implementations that are allowing us to do that to string. And then, or that would actually be serialize, would give us like what we need. Yeah, and you see here, we're T serialize. So by doing that derive serialize, as long as our data type has implemented that, we're good to go, right? So that's what we're defining here, where the type implements has an impl block for serialize, or in this case, we just derived it. So we did it for free, basically. Well, guess what? From string is going to require that we've implemented deserialize, and that's the only real difference. So it's going to be painfully easy to read in one of these files and deserialize it back into our struct. So how do we do that? Well, first we wanted, what is it? How do I want to name these? We'll go with the same naming because it's still a string. So we're going to say include string. Is it include string or str? And we're just going to say config.json. Yeah, that's not include. Yeah, include str. Couldn't read source. Okay, it's looking in source. So we're going to do that. And it'll go, it's looking in where main is at. So we're going to give it this to tell it to go up a directory, which is where these are all living. Doesn't really matter that much. Actually, I wanted to demo one more thing. I forgot something when I had been thinking about this before. Output file, we don't want a string. Strings suck. We want to do a path buff. I mean, strings are fine, but path buffs are better. So let's check this out. Let's run it again. And you should notice that, like, probably nothing changed. Output file, actually JSON 5, don't save. Output file looks the same there. Let's just reopen them though. There's probably a shortcut key or something to refresh. And you'd think I would know that because I actually use VS Code a lot. But we see here output file still looks the same. Nothing changed, right? But a path buff is actually better. And see, it's actually smart enough to create the path buff here from a string. So this is why it works in this case. But path buffs, what they allow you to do is a lot of smart things on top of the data type. So if we take config, I know we're not mutable, but output file, and we can do things like we can get an OS string, we can get as path, There's all, we could probably do a path instead of a path buff as well in this case. Yo, Tusk again. I know who that is. How's it going, dude? So where was I looking for? That startled me. Is directory. So these are the kind of things you're looking for. Is directory, is a file. You can run these checks on a path buff or a path that give you a lot of extra info. So like maybe you want to check something, like the user input something, and you want to make sure that they gave you a valid directory. So we would say .isdir, and we could do some kind of a check on that. If the config file is a directory, blah, that kind of thing. So this is why path buffs are actually, if you're going to be doing something like this, I would suggest using something like a path or a path buff. So there's also path as well. And in this case, I think it would work. It would work just as well. Let's actually confirm that. Config dot, what was it, output dot isdir. Yeah, that would work as well. And the reason this works in this case is because path buff, if I remember right, it implements the same trait and exposes basically all the same functions that path has. It can be easily, I don't know if it does a deref. Actually, we could read here. Yeah, it does a deref. It implements a deref to path, meaning that all methods on path slices are available on path buff values as well. So yeah, path buff is pretty cool. I like it. Detour, another one. Tusk has redeemed a hydrate. Thank you, dude. Okay, and back down, now that I'm done detouring on that, back down to the include string. This is a cool little macro. It literally just goes and grabs the file. This is one I didn't know about for the longest time. So instead of building out a path buff and all that crap, you can actually go ahead and just use this macro. And it's, you know, it might lead to some issues if you give it a bad file name. I don't know, I've never done that. But it's smart enough to know at compile time, yo, this file doesn't exist. I love that. So we can use this include string, and it's literally going to open that file and give us back a string slice, the ampersand str type. So we can use that now with the deserialize trait that we derived, and we can actually go ahead and get back to our original data structure. So this is how you read your config file into the program. So let's do this here. Let JSON config struct config. We don't need config there, but what we want to do is we want to say Serde JSON from string from stir, and we want to say JSON config, and it's giving us a result. So we want to unwrap, and if I, oh, it's not config, it's what was it, scraper config. No method unwrap on result. Why not? Oh, I misspelled it. That's why. So yeah, if we get rid of scraper config, I don't think it's going to complain. So we can either, yeah, we'll just give it the type there, and it's able to work from that. Perfect. So we are good to go there. I want to do this for all of them though. So we did JSON. Let's do JSON 5, Ron, and YAML. So this will take a moment. Boom, boom, and boom. And we're going to rename this one to JSON 5 config. Whoa. Hold on. Oh no, I already renamed that. My bad. I thought it just did that on its own. Dude, yeah, I heard about that, Tusk. Like I said, I don't know if you saw my message to you, but I'm glad you're okay through that. Um, that's it's crazy stuff, man. Ron from string and Serde Yaml from string. So this is going to be Ron config. And this one is going to be Ron config. And this one is going to be YAML. YAML config struct. I'm going like way overboard with the way I'm doing this here, just to really drive home that we should get the exact same thing from all of these, because if we were able to successfully serialize it and turn it into the files that we see over here, we should have no problem deserializing it back into the struct, you would hope. So let's take a look at that. And I should have actually done this first, but whatever. So we're going to do print line, and we're going to do, we'll just do that. We're going to say JSON config, boom, just like that. And I'm going to copy this down on each one. It's a bit of a pain, but it's the point of demoing things. You got to do it. Sometimes you got to do it the slow way. Ron config and YAML config, and we'll just pass in the struct for each one. Yoink and yoink and yoink. Okay, so let's do a build on that, see if everyone's happy. It's not happy, why not? Scraped info, where is that at? Oh, I thought that was happy earlier. Oh, it's not happy with path, but it is for path buff. Okay, something important to learn. There we are. Cool. Okay, I'll get to the rest of your messages in just a moment, Tusk. I want to finish wrapping up this train of thought. I'm not far off from being done here as well. So we got our build, we run it. We got a lot of crap showing up in the console here, but let's take a look at it. Actually, let's do this even better. I wasn't going to, but let's pretty print. Let's do a pretty print on each of these. Now, as I said, I want to try to explain most things as I do them, but I put this debug in without talking about it. For someone who may not know, debug it derives a macro generating an impl of the trait debug. Cool. But what is the trait debug? It is basically your debug representation of your struct or your enum. You can also do it on enums. And you see here I have debug derived for the command enum. So it defines, it basically automatically derives the debug representation. And that's what's allowing me to print these. So without that, I would either have to go define a function to convert it to a string or something. There's actually a better way to do that. Rather than defining a function, you would actually, you would implement the, I forget what it's actually called. I use debug for everything. It's been so long since I've implemented the other one. But basically, if you just try to do this, yeah, it's going to tell display. That's it, display. So you would have to implement the display trait, or the alternative is you would have to go through and say like this and say JSON config struct dot, whoops. What is happening? There we go. JSON config struct dot, and then maybe you would get max depth. So then you would say max depth, and then you would say output file And then over here, we want to go and get the output file. So JSON config struct.output file. And so on and so forth. We would have to manually put each one of these in. Yeah, I know pathbuff doesn't. So pathbuff doesn't implement display, but I know pathbuff actually does implement debug. So we have to do this for the to do debug printing. We have to do this colon question mark weird thing, and that tells it use the debug representation. So that's what's up with me being able to print all of my structs and not having to actually do anything manually. It's because we went ahead and derived debug on it. And so we just use the colon question mark thing, and then if you put the pound sign in the middle, you get a pretty print. And we'll see what that looks like now. It's just gonna put, you know, lines between everything. So what we see here is YAML config. We have scraper config with URLs, with max depth, with an output file, a bunch of commands, all that fun stuff. But what just happened is we read that from the file on the disk. So if I were to now comment out all of this other stuff, we're not making a config anymore. Except for this one. Let's see, there we are. We're not making a config anymore, right? So all we're doing is reading in configs from the disk. And yet we're still good to go. So this is how you can be a little bit lazy about it, and you can actually take you could like have Serde generate your config files like I did here. I can go in and now modify my config files. I can go in here and add 15 and then save that. We'll run it again. And now if we take a look at the YAML one, we actually see 15 was added here into the key combo. But if we look at another one of the key combos where I didn't add it, boom, it's not here. So that's as you would expect. It is dynamically reading these in now, and I don't have to create them in memory anymore like I was doing initially. This is all to demo how it works. But this actually gets to the other interesting thing, and this gets to something that I want to try. So this is actually the entirety of what I really wanted to demo today. But we can imagine something now. We can imagine that, let me recomment all this in. The commands are a little bit too busy, so I'm going to actually just delete them. They're cool and all. It shows a much more complex data structure for sure, but it's a bit overkill. So let's do cargo run there, and now we have something a lot more readable down here. Cool stuff. I like it. I'm a big fan. And we could also turn Toml back on now. Oh yeah, we did. So let me do this again for Toml as well. So we have Ron config.toml, because now we've removed the like complexity of the enums. So here we go. Toml config. Ooh. What did I do? I killed main. Toml config struct. Toml config. Config.toml. I think I got all the tomls in place. Not that one though. It'd be better to maybe abstract this a little bit, but the point of demoing, I mean, all these unwraps, you don't want all those unwraps. Not in something real. All right, cargo run. Now we can see the YAML config, we can see the toml config. If we open up config.toml, nice and simple, you love to see it, right? So that's it. Now we can imagine though that what we've done is we're actually building a real web scraper, right? So we now have let config equal YAML config. I was going to do that because I don't want to call it YAML config. I'm being lazy. Oops, no, it's struct. My bad. YAML config struct. Okay. So now we have a config file. And let's say we're building our web scraper, right? So we actually want to go scrape these web pages for URL in config.urls.iter, and then I'm scraping that URL, and boom, I'm scraping Google, I'm scraping CNN, I'm scraping Fox, I'm scraping potatoes. Boom, we're good to go, right? So we could actually do some scraping here. And then, you know, you could do your stuff with the max depth and all that. We're not really going to go into that here. This is not about web scraping. This is about configs. It's about Serde. But here's where I want to get into something a little more interesting now, at least to me. I've built web scrapers before. I built a search engine before. Nothing. I mean, I use, like, you know, some like real algorithms. I took a graduate course on information retrieval, and we built a search engine there. And we limited it to our university's domain, however, so we didn't want it going out and scraping random websites. But like I could do that. That's fine. That's not an issue. And maybe I'll do another one day. But what I'm actually more interested in right now is directly related to Serde and what we can do with Serde. So I had this idea, and I don't know why. I don't know why I would want to do this. I don't know why anyone would want to do this. But I had the idea that we could, we meaning me, I guess. I always refer to myself in that way. I had the idea that what I could do is write a program that allows you to give it a config file in one of its supported formats, and let's assume it's any of these. Give it a config file. The program will actually read in that config file generically, meaning that we don't have an explicitly defined struct like this, where it's expecting URLs and a max depth in that. We might have some generic struct that says this is what these are the valid element types of a JSON file or something. We might be able to work with something like that. I'm not exactly sure yet, and this is why it's something that I think I might turn into a larger project. But what I'd like to do is take in a file, deserialize that, and then reserialize it into another format. So let's say you have a JSON file and you don't want JSON. Oh, you know, we could also use XML. We could throw XML in here too. But yeah, let's say you have a JSON file and you don't want JSON, you want XML. Well, why not have a program that lets you convert JSON into JSON 5? Well, that's not really different, so we don't care about that. JSON 5 is a superset. Or RON, or TOML, or YAML, or XML. Wouldn't that be interesting to be able to do all of that from a single program and dynamically without having to define this is my exact struct? I don't know how easy that is, but I think it would be interesting to try. So it's something I want to start looking into, and I might turn into a full project. So what I actually want to take a quick look at something here. So we're going to go to the browser again. And oh, what is this? What was I going to say? XML Serde. Let's add XML. Serde XML RS. So we'll just go here. You know, you want to be really lazy? Just go click on that little clipboard there. That's our dependency. So let's flip back over to Visual Studio Code, and boom, there we are, newest version, Serde XML. That's not actually what we're going to type. It's probably going to be underscores. So let's see. Let's go to the last one here. Ron, that's good enough. All right, we're going to change this to XML config. I just want to see what it looks like. I'm interested. Alrighty, though. That's basically going to do it for today. Is there a toString? Yes, there is. You'll love to see it. Config.xml. XML config as bytes. All that fun stuff. I feel like I've missed something, but everything looks okay. So let's go ahead and go through there. Let's Grab that. Perfect. XML config. Cool. Now, XML config may give us some issues, though, and this is why I'm actually interested enough to try it. Serde. XML is a bit of a weird format. Oh, it's because it doesn't exist yet. Yeah. So if I try to build, it'll fail, right? Yeah. So this macro is actually smart enough to resolve that at compile time. Gotta love Rust, right? So just make a dummy file there and cargo run. And now it panicked. Unsupported operation serialized sequence. Now that's probably because XML doesn't actually have like ordered sequences. I'm guessing that's why. Typically in XML, if you see something with like an ordered sequence, it actually has to come with values that say, this is the first, this is the second, this is the third. And then when you, whatever your code that deserializes it, it has to be able to look at those numbers and order things as intended. So XML can be a pain in the ass. And we see there that XML doesn't quite work in this case because of that. So that would be something where what you would actually do, and you know what, just because I can, I'm gonna say we're gonna go match. I like doing match statements to handle my errors instead of unwraps are not the greatest. I like doing match statements. And there's other things. There's like unwrap or else. There's a lot of ways you can handle this. So this is a name. You can call it whatever you want. You know what? I'm gonna call it elephant. It really doesn't matter. You're naming the value that came from the OK variant. And then here, I'm feeding that OK variant. I'm spitting it out of the match block and assigning it to XML config. Typically, I would call it XML config, but we're gonna call it elephant today. And then in an error, I'll do this, and I'll make a little block here. Error serializing XML, and we'll print it. And then in this case, you might just panic. To be fair though, if you were gonna panic, you would probably, do this. I think panic lets you feed in values. Yeah, so you do panic instead of print line, but my point here was that I'm going to feed back a default string, an empty one. Whoops. There we go. So we don't use the semicolon here, and that means we return this value, if you will. This value gets spat out from the match arm here, from the error match arm, and fed back to XML config. So we'll actually get an XML config, but it's empty. There'll be nothing in it. So there it is. And you see we failed later on. Where is it at? We failed later on because that's actually not XML. So there's nothing to deserialize there, which again, you would want to do something like this. Just demo it. Match on that. Okay. Elephant. And then here it's going to be the same kind of deal. Except I need to actually build out one of those, so. So it's scraper config, and we don't put a semicolon there because we're actually spitting this value back out. And there we are. So I've made a default config, kind of a goofy one, but we look at the XML one. Error deserializing XML, syntax 1.1, expect unexpected end of stream, no root element, but we have a config now. A better way to do this is to copy that. Do this, and we're gonna say, actually, and I never know what I need to implement, so we just implement missing members. So we're going to import default for scraper config, and it's going to basically, it already has defaults that it can do this for itself. You can actually derive it. But what I like to do instead is this. I like to define my defaults more explicitly like that. So that's cool. So now, instead of doing this down here, scraper config, default, and we should get the exact same results because nothing's changed. So where is it? Ah, here it is. Yeah, XML config, scraper config, all good. So there we are. A little bit of an extra crash course in some ways. Now I want to go ahead and say what I've said a couple of times already. In programming, when you do something one way, there's 80 other ways to do it. Just because you do it one way doesn't mean it is the only way, doesn't mean it's the right way, but everyone can kind of come up with their own styles in a way, but we got to be careful with that because there are, for good reasons, there are what you would say conventions in languages. So you try to stick to conventions because if you look at somebody else's code, you want to make sure that it is following a lot of the same general conventions as your own code. It makes it a lot easier to jump between different different repositories or whatever, especially, you're working with a group of people. If you all wrote completely differently, that'd be very difficult to follow. So I want to follow conventions, but in general, sometimes one person may decide to do a loop on something, another person might decide to do a map, so we could do here. Let's see. So instead of that loop there, actually I'll do it both ways. config.urls.map, and then feed in that URL. What's going on, Otter? JHP Otter, how you doing? I'm about to wrap up. I actually am wrapping up, but it's good to see you here. How are you doing? Oh, I need to get the iter, my bad. Tusk was hanging out a minute ago, but unused map that must be used. Yeah, that's not what I need to do. I would do a for each if I'm trying to do this. There we are. Yeah, see, there's Tusk. And so my only point here is that there are always different ways to do the same thing. So if I've shown something today that maybe it's like, I wouldn't do it that way, or I would do it a different way. It depends. There can be arguments to be made, but sometimes in a case like this, doing a for each here with the closure versus a for, it really depends. This is a really simple case. It's just made to demo something, so I don't know, it almost makes more sense to do a typical for loop. You said, Tusk, you said wraps rule. What about unwrap? What about unwrap? Oh, too many zooms. Unwrap. Alrighty. So yeah, just to recap what I've talked about here, I'm going to end the recording and I'll hang out here for a minute and chat with you. But I'm going to end the recording after this quick little recap. So what I did today is I kind of had the idea of, again, this is the first time I've ever tried a coding stream, so I thought it'd be easy to do a little demo and just kind of show some of the stuff you can do with Serde, and how you can use it to lazily generate config files, at least your initial config. And although it's removed now, I had added a pretty complex enum, and I had a vector of those complex enums as part of my scraper config here. And so that was a thing that I didn't even know the correct way to write something like that in JSON or in YAML or really any of these config formats that I'm looking at here. So by simply building out like a dummy struct in Rust and using Serde, converting that to a string, serializing it down into a string, and then writing that to a file, it's able to take away a lot of the work for me and get that initial format set up for the config. So it allows me to be lazy, because I would rather write Rust than like figure out how does JSON want me to write this gross thing. And yeah, dude, I don't like using expect. I don't even use expect normally. We'll get back to that in a minute. So yeah, as a lazy way to generate those config files, because I'd rather write the Rust to do it than actually figure out how JSON or how YAML or whatever wants like a nested enum and garbage like that, because I don't know what they expect from that. So it's a lazy way to do it, but then also showing how you would read in those config files once they're actually on your disk using the deserialize, which we have here from the from string functions attached to each of the different crates that I pulled in: Serde JSON, JSON5, RON, TOML, Serde XML RS, Serde YAML. So that shows you how you can kind of pull those configs back in. So this is basically a way to decouple all that stuff from your actual code, because you don't really want to be putting that kind of stuff in your code. You want to separate that. So that's the kind of the high level quick demo. And then my idea, I'm sure it's been done before, probably even in Rust, but it's something that I think would be fun to do on my own, is not actually build this web scraper, because I've done that before anyway, but is the idea of building out a program that allows you to feed in any of supported file types like YAML, or basically these file types that we see here. I would like to be able to feed these file types into the program and have it generically be able to deserialize that, which that would be the interesting part to me, without explicitly defining something like this scraper config struct here, and then be able to reserialize that into another format. So again, if you're working on something and you have a JSON config and you want to convert that to a YAML config or something, I want to make a program that does that, but all generically. Maybe I want to feed it JSON and get back TOML. It doesn't matter. I want to be able to try to build something like that. That sounds like it'd be a lot of fun for an upcoming project of mine. So that's the high level there. That's kind of everything that I went over here. So I'm actually going to end the recording here, but I'll hang out for a minute and I'll talk about that expect and unwrap and stuff, and I'll talk about what Tusk was saying earlier too. So yeah, if you're watching this on YouTube, I know it's gone on for a while, but thank you. Go ahead and do that, subscribe, all the fun YouTube stuff.